Hello folks. So these are the notes for section 57, and you should have these written down already, but I'll refer back to them as we're working through some examples. I'm going to start with example 3 because it's just a little more complex, and I think you can do those early ones. We worked on LCMs in pre-algebra and even up into 5th and 6th grade. So we're going to start with example 3, and example 3 gives me the terms 6p squared s cubed, 2m squared s squared, and 8m cubed p. So if we go through our list, it's basically I'm asking myself, do I have any number parts? Which I do. I have 6, 2, and 8. Do I have any variable parts? Yes. I don't have any sets. And what I mean by that is, do I have any addition or subtraction anywhere? No, I don't, okay? So I'm gonna start with this guy, and it says that I'm supposed to tree method the number part. So if I break this down, this breaks up into 2 and 3. I'm done. Those are both prime, so this would be 2 times 3. This guy is obviously prime, so he's just gonna come down to this. And then 8 would break down into 2 and 4, which would break down to 2 and 2. So we could say 2 times 2 times 2. Or I know you've been taught to use exponents, so you could say 2 cubed as well. That's probably best, actually. Okay? Now, if we take back up a look at our notes, it says after we do the factor tree, we're supposed to take the most of each factor. So like when I'm looking through these answers, I have 2s and 3s, right? He only has 1, 2. He only has 1, 2. They have 3 2s, or they, she. We'll call her a she. She has the most 2s. Okay, so I have to have 2 cubed. Okay, this guy has 1, 3, 0 3s, 0 3s. I have to have 1 3. Remember, I have to take the most that one person has, at least one person has. And I know they're not really people, but terms, you know what I mean. Okay, so that took care of my number piece. This would be 8. 8 times 3 is 24. There's my least common multiple between 6, 2, and 8. Now, I'm going to do something similar with the variables, except I don't have to tree method them. It says, look at each variable, take the most of each. So like when I look at these 3 terms, I have P's, I have S's, and I have M's. Okay? So I go in alphabetical order. M would be first. Okay? He doesn't have any M's. This guy has 2, and this gal has 3. I'm going to take the most. Then I'm going to move on to P's. 2, none, 1. I'm going to take the most. Then I'm going to move on to S's. 3, 2, none. I'm going to take the most. There's my LCM out of all 3 of those terms. Okay? All right? Now, sets is also a little bit difficult, so let's take a look at that as well. The first one that they give us just looks like this, 3x plus 1 and 2x plus 9. Now, let's remember our notes. It says, if you have sets, factor each. Okay, so meaning 2 terms, can I take anything out? No, I cannot take any numbers out of 3 and 1, and I cannot take any variables out because they both don't have variables. To do the same thing over here, I can't take any numbers out. No number will come out of 2 and 9 evenly. And they both don't have variables. Okay? So then it says, take each set, and what I mean by this is, if they repeat sets, you don't have to take them, but we'll find the LCM of them and of their leading coefficients. Well, we didn't take anything out, so we don't have any leading coefficients. All right, but it does say take each set. So I have to have 3x plus 1, and I have to have 2x plus 9. Done. Okay, because remember, I can't split this up, just like when I was simplifying. I couldn't like take a 3 out if 3 doesn't go into 1 evenly. I can't cancel anything there. They have to stay the same. So just like here, when I had to take 2s and 3s, I have to take a 3x plus 1 and a 2x plus 9. Those are both terms. Now, it can get a little more complicated, and I want to show you that with example C from example 4. So they give us 60x cubed plus 24x, and they give us 45x to the 4th plus 18x squared. Okay. So again, we have to factor, okay? So I'm gonna look at my numbers first. 60 and 24, let's see here. Well, they're both even, so I could definitely take 2 out. I could take 4 out. 5, I could take 6 out. 8 doesn't go in evenly. I could take 12 out. So I'm gonna pull a 12 out front, and then I'm also gonna look at their x's. Now remember, with this, I'm taking the least, what they have in common. So they at least have one x in common. Sorry, I should have given myself more room there. Okay, now I'm gonna divide. 60 divided by 12 is 5. X cubed divided by x, x squared. Plus 24 divided by 12 is 2. X divided by x, that cancels. And I'm gonna glance one more time. I can't take any more numbers out. Can't take any variables out. Okay, now I'm gonna do that over here as well. 45 and 18. 9 would be my number I could take out. And I could take 2 x's out. 45 divided by 9 is 5. 4 x's, taking 2 out, gives me x squared. 18 divided by 9 is 2. X squared cancels. Now, I'm going to have to find the LCM between 12 and 9, between my variables, and between my sets. Okay? So I'm going to tree method this 12 here kind of small. 2 and 6, 2 and 3. So that gives me 2 squared times 3. And then this would just break down to 3 and 3. So 3 squared. So if I'm trying to find LCM, I'll start with 2's. This guy has 2, this guy has none, so I have to have the most. This guy has 1, 3, this guy has 2, I have to take the most. Now let's talk variables. X squared, I have to take the most. And now let's talk sets. Remember it said take the most of each set unless they repeat. These are exactly the same, so I only need one of them. Now I just need to clean this up. 2 squared is 4, 3 squared is 9, so that gives me 36 x squared, 5x squared plus 2. That's my LCM. Okay. All right. Okay. If you have any questions on those, holler at me, okay?